Hello and welcome back to lesson 4.3, the second part of rational exponents. So hopefully at this point we are familiar with working with rational exponents, and really the idea that the denominator of the exponent corresponds to the root. So either you're taking the square root or the cube root or the fourth root or the fifth root, and that corresponds to like that base to the power of 1 over 2 or 1 over 3 or 1 over 4 or 1 over 5, etc. Really using that in terms of how we're going to do future questions is going to be important. So again, here I'd actually pay sorry, give me 1 second again. Okay, we're back, and again, you have to be careful about the wording. Evaluate just means just like find the answer. But if you have to simplify and then evaluate, which is actually what this question is asking you for, you have to kind of reduce things to the lowest possible or the simplest terms before actually evaluating it. So that's actually what we're going to do here. You could technically, again, put 64 squared in your calculator, put this in your calculator, divide them, you would get an answer. But that's not what we're going to do, because A, we're not allowed calculators even now, and B, because we haven't simplified it yet. So the idea here is we're going to use our division rule, so that's subtraction of exponents. So this is, again, times 3. Denominator is 1 times 3, so divided by 3 is 2 times 3 is 6, minus 2 is 4 over 3. And again, we know that this is just the cube root of 64 to the power of 4. Cube root of 64 is 4 to the power of 4. 4, 16, 64. 64 times 4 is 256, I believe. And that's the full, because again, this was my simplest terms. I can't really simplify that anymore, so I'm evaluating at that point or that stage in my calculation. Here we'll be careful. There's a negative sign, which means I can't really simplify this because there's no rule for subtracting two bases, right? There's no rule for that. So we are gonna just evaluate these things now. So 4 squared is 16. Now we have to do 4 to the power of 3 over 2, which is not that bad because, again, first we're going to take the square root of 4, and we're going to take the power of 3. Square root of 4 is 2 to the power of 3. Ta-da! That was hopefully easy. This seems suspiciously easy. This is just 5 squared is 25 divided by 3 squared is 9. Yeah, that's it. That was an easy one. All of them are easy ones. Am I right? Or am I right? This doesn't seem to be a big lesson. We'll go over the homework. There's going to be some challenges there, I'm sure, hopefully, because this is too easy right now. Again, here you can do this. Well, I'm going to take the fraction as a whole only because I know that there exists fourth roots for both 16 and 81. So I'm going to take the fourth root of 16 over 81 as a whole, and then I'm going to take that to the power of -3. Again, an option would be to first do the negative. You could actually make, you have to flip the fraction 81 over 16 and then make the exponent positive 3 over 4. You could do that, in fact, but the idea here, either way, you'd get the same answer. It doesn't matter where you put the negative, because here, fourth root of 16 is, in fact, 2. Fourth root of 81 is 3. And now I'm going to apply the rule, so I'm going to make this 3 over 2 to the power of 3. Again, changing the sign by flipping the fraction, changing the exponent by flipping the fraction. And after this, it's just evaluation. 27 over 8. Let's take a look at this guy. Doesn't seem too hard. First power of a power. This is 9 squared divided by 9 to the power of -0.5. Again, division rule. 2 plus 0.5 is 2.5. which actually I'm going to write as 5 over 2, which again is just the square root of 9 to the power of 5. So square root of 9 is 3, to the power of 5 is, to the power of 5, so 3 to the power of 5 is 81. Let's take a look at this question. Again, I have a plus sign here, so I can't really move things numerator, denominator. I have to work with the fractions. So 1 over 3 to the power of negative 2 is 1 over 3 squared, which is 1 over 9, plus 1 over 2, divided by 8 to the power of 1 plus 4 over 3, because I'm using the multiplication rule. I add the exponents here. So this is, obviously I have to take a common denominator, and I have to take a common denominator in the exponent part of this. So this is 2 plus 9 is 11 over 18, divided by 8 to the power of times 3. So 7 over 3, I think. So this is 11 over 18 divided by cube root of 8 to the power of 7, which is in fact 11 over 18 divided by 2 to the power of 7, which is 11 over 18 divided by, what is 2 to the power of 7? 128, which is 11 over 18 times 1 over 128, which is 11 over something. Do I have to take out my calculator? Sigh. Life is so hard, you know, sometimes. 18 times 128. 2304. Ta-da. Okay, that's the answer. So hopefully, again, it will take a bit of practice to be, you know, familiar with this and kind of get used to doing these things. I'm just looking at the answer key here. It says ignore worksheet 4.3. I think there is a worksheet 4.3 up on the hub. It just says 4.3 rational exponents. I don't know if you... Yeah, okay, apparently we're just, if you can't see it when when you're like doing this work, you just ignore it, and we're gonna continue with our questions from the textbook. And again, like as you'll see here, the time here is just 8 minutes, so this was a fairly quick lesson. And again, it's just combining a lot of the things we've done before. You just have to be familiar with, as long as you're very good with, you know, the integer part and the rational part. And this is just putting it all together and combining it in one big lesson. So if you have any doubts with this, I'd recommend going over the previous lessons to really make sure that you understand what's going on. But we are going to take a quick look at some of the homework here, 3, 5, 6, 10, 14. And we'll just look at the hard questions, really. See, right is a single power. So this is just addition. This is just subtraction, addition. This is multiplication rule because it's power of a power. So I'm going to do some cross cancellation. Just make that -1, which is 1 over 7. Again, doing that should be automatic. This is just subtraction, but you have to be careful because you have to find a common denominator in the exponents. This is addition, so like this is 10 to the power of -4 over 5 plus 1 over 15 minus 2 over 3. The common denominator is 15. And you kind of have to work from there here. So times 3 times 3. So -12 plus 1 minus 10, which is actually -21 over 15. If we were to simplify that, you would get -7 over 5. Which is again just, oh, it's only single power. You don't have to calculate it. So that would basically be it. If you wanted to write 1 over 10 to the power of 7 over 5, that would be fine. But single power, like, I think a negative is fine. You just know that it could also be written like this, but single power, then evaluate. Oh, there's some tricky ones here. This is 5 to the power of half times 5 to the power of half, which is 5 to the power of 1. This is, again, you have to write, so first we have to write this as a single power. So 16, first we're going to write negative 16 to the power of 1 over 3 divided by 2 to the power of 1 over 3, which negative 16 to the power of 1 over 3 is actually, in fact, negative 2 to the power of 4 to the power of 1 over 3. But the negative is outside because if I took negative 2. So again, I'm just leaving the negative outside for the time being and just making that 2 to the power of 4 to the power of 1 over 3 and then taking the negative of that. Actually, I'd have to write this differently then. Doing this in a single power is kind of annoying. So I had to take 2 to the power of 4, take the negative of that, and then do that to the 1 over 3. Because of this negative, there's like no really easy way to... Okay, this negative is going to make the bases not the same, so I can't really do anything about that. This is just a single power. You just evaluate this. Yeah, so cube root of 16 does not exist, so very annoying. Actually, I could write this as negative 2 to the power of 4 divided by 2 to the power of 1 over 3, which is actually negative 2 to the power of 3 to the power of 1 over 3, which is actually negative 2 to the power of 1, which is actually negative 2. So that appears to be the answer here. So I can't simplify it. And the key here is grouping the 1 over 3. Otherwise, it kind of gets confusing. So, yeah, that was kind of tricky. Let's try C. Again, here I don't have a common base, but I know square root of 28 is just square root of 7 times square root of 4, and then times square root of 4 divided by square root of 7. So, it says I mean, I can do some cross-canceling here realistically if you just want to evaluate this, but if you are really looking for a single power, this would be 7 to the power of 0, because I do 7 to the power of half minus half. So 7 to the power of 0 times 4 to the power of half plus half is 4 to the power of 1. So this is 1 times 4, which is 4. Again, D is also very, very similar because I have to break up fourth root of 18 into the fourth root of 9 times the fourth root of 2. That's just the fourth root of 18. Then I still have fourth root of 9 divided by fourth root of 2. And again, here, essentially what I have is 9 to the power of 1 over 4 times 2 to the power of 1 over 4 times 9 to the power of 1 over 4 divided by 2 to the power of 1 over 4, which is just 9 to the power of 1 over 4 plus 1 over 4 is 1 half. 2 to the power of 1 over 4 minus 1 over 4 is 0. So 9 to the power of half is just square root of 9, which is 3 times 1, so the answer is 3. Yeah, that was kind of tricky, but good to know these things. I don't think that was technically part of the homework, but it's also very good assignment questions like we talked about. So, sorry. Let's see. I think you should be able to do most of these questions. It's just evaluating stuff. So just, do them separately and calculate. Separately calculate, separately calculate. Yeah, this is not hard. You should be able to do all those things. Write as a single power, then evaluate. What trickery is this? 4 to the power of 1 over 5 plus 3 over 10. Again, I'm going to convert everything to a fraction, which is just 5 over 10, which is 1 over 2, which is like, 4 to the power of half is 2. Here we have, 2 over 10 minus 7 over 10 is negative 5 over 10, which is negative half. So this is 1 over 100 to the power of half, which is 1 over 10. So you can try that. Here again, write a single power, so 64 to the power of 4 over 3 minus 1, which is just 1 over 3, which is 4. So again, combine the exponents using division rule. Combine exponents using multiplication and then division rule. Just make sure everything is in like fractions. So you can say this is 5 over 2. This is 2 over 10, which is also 1 over 5. This is 3 over 4. Combine everything and then just add. Then just evaluate. Again, just combining things with the rules. What else were we doing? 10 and 14. Okay, let's take a look. The volume is 0.015625 meter cubed. Determine the length of each side. We know we're doing the cube root of that. And again, if you could, and okay, hopefully I don't know. Some people were confused about this on one of the assignments. This meter cube is a unit, right? That's the volume. Units of volume are, units cubed. And when you calculate the length of each side, the units are then going to be in meters. So hopefully we're fine with that. Again, calculating the cube root of that is, you can just use a calculator. I don't think that's out of the rules. So just take the cube root of this number, and that answer in meters would be your answer. Let's see, what else do we do? We're doing 10 and 14, right? Can you do 12? Yeah, you can do 12. Again, it's just taking the cube roots of these numbers. Well, not in this case, but yeah, should be doable. You said 10, right? Explain why negative 100 to the power. Again, here, very simple idea that the negative is part of the base. So this is actually negative 100 to the power of 2 over 10, which is negative 100 to the power of 1 over 5, and this is technically the fifth root of negative 100. And although this is going to be a weird decimal number, it does exist because you can take the roots of the odd roots of negative numbers. But here, this is actually negative 100 to the power of half, which is the square root of negative 100, and you cannot take the even roots of negative numbers because they don't exist, because you will have some number to the power of 5 that gives you negative 100. But there's no number that, if you square it, will give you negative 100. That is impossible. So that's why you have to explain. So odd roots of negative numbers exist, but even roots of negative numbers do not exist. Yeah. 14, state whether each expression is true or false. So we know that there's no rule for adding bases. You can't just combine the exponents like this. This is completely false. Again, adding bases, there's no exponent rule, false. Again, I have something that is added here. I can't just flip this and flip this because this is a negative 1. And there's an adding. This is a binomial, so I can't just, that's like saying like 2 plus 3 to the power of negative 1, which is in fact 5 to the power of negative 1 is just 1 over 2 plus 1 over 3. And the idea here is that 1 over 2 plus 1 over 3 is not equal to 1 over 5, right? So obviously it's 5 over 6. And so that's not true. So false. Let's take a look at this one. This is true because 1 over a times 1 over b is just 1 over ab to the power of negative 1. And I'm just flipping that fraction, making the power positive, or moving this to the numerator. Again, because I'm adding it, I can't just put the 6 in here. Be very, very careful. There's the same reason you can't just do a plus b squared is not just a squared plus b squared. It's a squared plus b squared plus 2ab, right? So same way here. If there's an adding here, you can't just do the 6 here and the 6 here. It's just false. Here, actually, you can because there's a multiplication. So 6 goes here, 6 goes here. 6 divided by 3 is 2. 6 divided by 3 is 2. This is correct. So again, very, very careful to be able to do these things. Let's take a look at this. Again, this is solving for x. I guess technically this is grade 12 stuff, but this would be good to put on an assignment question. So, just take a look at it. 1 over 8 to the power of 1 over 3 minus x to the power of 4 over 4 plus 15 equals 4 through to 16. Solve for x. Okay. This is 1 over 2, of course, minus x plus 15 equals 2, 4 through to 16. Then I just move stuff around. 1 over 2 minus x equals negative 13. Negative x equals negative 13 minus half. That's negative 13 and a half. So negative x equals 13 and a half is negative 27 over 2. So x equals 27 over 2 should be my answer. And yeah, otherwise, again, this is just square root of x squared is just x, right? So you just evaluate this, which is, again, 1 over 16 to the power of 1 over 4 minus cube root of this, which is 1 over 2 minus 2 over 3, which is 3 minus 4, negative 1 over 6 equals x, so that's my answer. Yeah, that's it. So, again, that's actually not grade 12 stuff. You should be able to do this. There's no weird things. So, yeah, okay, that was that lesson. So hopefully we're okay with rational exponents and everything to do with rational exponents. Simplifying algebraic expressions. Now we're going to obviously move away. As you can see, the difference here is we're moving away from numbers and going to variables. And of course, there's big algebraic expressions where this gets quite complicated, as we can see in cases like, whatever the heck this stuff is. But again, very, very easy as long as you are familiar with all the individual rules. So we will see. I will talk to you very soon. We'll be doing 4.4 and 4.5 over the Easter weekend, and then we'll continue with the rest of the unit, which really goes into graphing exponential functions. So we have like 5 more lessons of that, but we'll get there. Slow and steady, right? Yeah, and we have pretty much until May, I think, and after this, I think before, schools are not opening until May. Before that, we should be done, I think, this unit and the trig unit, at least. The trig unit is quite big. It's like 2 different units, so it's not another thing to scoff at. We might get through half of that, but we'll see where we're at. I'll keep posting the videos until you're back in school, at least. If you're back in school, you'll be having lessons with Mr. Tremoli. So, yeah, you'll be going to school, obviously. Yeah, we'll continue this for the time being. Hopefully, everybody's socially isolating and staying safe and healthy. Until next lesson, I will see you guys. I will talk to you later. Peace out.